Okay, on section 13.9, we're multiplying and dividing complex numbers. And I think I'm just going to start with some multiplication. So I've got 8 times 2 plus 3i. So on this one, we are just distributing like you are already familiar with. So we do 8 times 2 gives us 16. 8 times 3i is 24i. So we're done with that one. If I have 3i times 4 minus I. Okay, we're still distributing. 3i times 4 will be 12i. 3i times negative I is going to be a negative 3i squared. Now, one thing you're going to want to remember on this section is whenever you have an I squared, that equals negative 1. So anytime we see I squared, we are going to replace it with negative 1. So for this one, I've got 12i minus 3, and this I squared is going to be negative 1. So then 12i and a negative 3 times a negative 1 is positive 3. Now we would be finished with this one. However, I think Hawks is going to want you to write your answer in the form of complex numbers that we did before, where you have the real part first. Sorry, I was going to do this as A. We had it written as A plus BI for complex numbers, which is just having the real part come first. So over here, the real part of this is 3, and the imaginary part is the 12i. So I would write these in this format. I don't think Hawks will accept it if you write it in the other format. I could be wrong on that. Okay, so another one. Square root of 3i times 2 minus the square root of 3i. And I wanted to do this one because Hawks sometimes presents them in this way, and when they have a radical with the I next to it, I like to rewrite these where I have the I first. So I'm going to have I times the square root of 3 times 2 minus I times the square root of 3. And that's just so that I don't confuse the I for being underneath the radical. So I'm going to switch it this way just to make sure that I keep my I on the outside of the radical. So then we're just distributing. So this I times 2 is going to be 2i square root of 3. The next one, I times I, is I squared. And when you do the square root of 3 times the square root of 3, you get the square root of 9, right, which is 3. So when you multiply the radical by itself, the same radical by itself, it cancels out the radical. So that will just be 3. So then I'm going to replace this I squared with negative 1. So I have 2i times the square root of 3 minus, this is going to be negative 1 times 3. So 2i times the square root of 3. And here, actually this is minus. When you have a negative 1 times 3, that's a negative 3. So when you have minus a negative, it's going to be plus 3. And again, you just want to have the imaginary part after the real part. So I'm going to rewrite this as 3 plus 2i times the square root of 3. Okay, so this one we are going to be foiling. And so hopefully you remember how to foil. Nothing changes about it. We just have complex numbers here. So negative 3 times negative 1 is 3. That's your first terms. And then your outside terms. And negative 3 plus 2i is negative 6i. And then our inside terms, 5i times negative 1 is a negative 5i. And then your last terms, it's going to be a positive 10i squared. And then we're just going to simplify. Here I have this negative 6i, negative 5i. So that's going to be negative 11i. And I've got 3 plus 10. Again, I have I squared, so that's going to be negative 1. So 3 minus 11i. 10 times negative 1 is going to be a negative 10. And then I still have this negative, or this 3 minus 10. Those are like terms. So 3 minus 10 is negative 7. Negative 7 minus 11i. Do division. Okay, so on the division ones, you need to remember that you cannot have an imaginary number in the denominator. It's very similar to the section when we had radicals. We can't have radicals in the denominator. And when we have radicals in the denominator, we multiply by something that's called the conjugate. And the conjugate is basically just whatever the denominator is with the opposite sign. So for this, I have 1 plus 3i. The conjugate is going to be 1 minus 3i. So when you're multiplying by that, you're going to multiply, you figure out what you're going to multiply by looking at the denominator, use the exact same terms with the opposite sign, and you're going to multiply the numerator and denominator by that same, by the conjugate. So then I'm going to have, we're multiplying. All right, I'm just going to put parentheses around these. So in the numerator, I'm basically just distributing. So 4i times 1 will be 4i, and 4i times negative 3i would be a positive 12i squared. And then in the denominator, I'm foiling here, so 1 times 1 is 1, 1 minus 3i, 1 plus 3i, and then 3i times 3i, well, positive 3i times negative 3i is a negative 9i squared. So now, in the numerator, I'm going to replace this 12 with negative 1, this I squared with negative 1. If I can erase that. So I've got 12 times, this is going to be negative 1 because it was I squared. And in the denominator, this negative 3i and positive 3i cancel each other out. So I have 1 minus 9, that I squared again, so times negative 1. So in this numerator, I'm going to have 4i minus 12. And in the denominator, I've got 1 minus a negative 9, which is going to be a positive 10. So, two things. Hawks will want you to have this as two separate fractions. So I could write that as 4i over 10 minus 12 over 10. However, we still need to have the real part first. So I'm going to switch the order on that. So I've got 12 over 10 minus 4i over 10. And then, oh, that was negative 12. And on these, each of these will reduce. So I'm going to divide them both by 2. 6 divided by 2, or 12 divided by 2, 6 fifths and 2 fifths. So they won't always reduce, but on this one we could reduce. Okay, I just now noticed that I made a mistake way back here in the very beginning, of course, when I distributed 4i times negative 3i should have been a negative 12i squared, which means this should have been negative. So a negative 12 times a negative 1 would be a positive 12. I'm sorry. It's going to be a positive 12. So that is a positive 12. Goodness. I'm sorry. So I will erase that. Maybe we should do another one. So this one will be a little bit different, but I will. Okay, so again, we're dividing. We can't have an imaginary number in the denominator, so I'm going to multiply by the conjugate. It'll be 3 plus 4i. Do the same over here, 3 plus 4i. So I'm basically going to be foiling each of these. So for this numerator, a negative 9 times 3, it's a negative 27. Negative 9 times 4i is a negative 36i. Negative 6 times 3 is a negative 18i. And then a negative 6 times 4i, it's a negative 24i squared. I'm going to FOIL the denominator. 3 times 3 is 9. 3 plus 4i is going to be 12i. 3 minus, or negative 4i times 3, it's negative 12i. And negative 4i times negative 4i, it's a 16i squared. And so then I'm going to simplify these. So one thing I'm going to do here, we know that this I squared is negative 1. So if this is negative 1, it's going to change this sign, and it's going to be plus. This I squared is going to change this one to be minus. This 12i and negative 12i cancel each other out. So in the numerator, I've got a negative 27. This negative 36 and negative 18 is negative 54i. And then we determine this is plus 24. And in the denominator, I'm going to have 9. This was minus to begin with. It's now plus. I am having a time with these negatives. Okay, right, so a negative times a positive is a negative. Then we have this I squared, which is going to make this positive. So 9 plus 16. And then a negative 27 plus 24 is negative 3 plus 54i. 9 plus 16 is not 24. It is 25. Okay, I'm going to have to give up on this tonight. Oh, man. Negative 3 minus 54i over 25. And you need to have two separate fractions for this. So negative 3 over 25 minus 54i over 25. Okay, I'm sorry. I hope I didn't confuse you on those two. I'm sorry about the negative situation. Let's see. I'm going to try to wrap this up since I'm messing up. I am going to also talk about what if we have I raised to a different power. Okay, we know that I squared equals -1. So if I have I to the 5th power, we could write that as I squared times I squared. That's 4 times I, right? And then we could come down here. We've got -1 times -1 times I. And then a -1 times a -1 is a +1. And a +1 times I is just I. So we'd have I to the 5th equals I. And that's fine, we could do that, but if we have like a bigger number, we'd have I to the 15th, and we try to write this in terms of I squared. We'd have to write this out as I squared. There's 2, 4, 6, 8, 10, 12, 14 plus 1 more, right? So we'd have to write these all out like this. And we'd replace each of these with -1. Not the I, because it's just that. And so then we have 1, 2, 3, 4, 5, 6, 7. So if you remember, when you have an odd number of negatives, your answer is going to be a negative. So a -1 times itself 7 times is going to be a -1. So we'd have a -1 times I, and a -1 times I is just -I. But if there's a shorter way to write that, so what I could do here is I can take this 15 and figure out how many I squareds there are. So if I divide it by 2, right, 15 divided by 2 is 7. So I could have I squared to the 7th power, because 7 times. 2 times 7 is 14. That leaves us with 1 more. And then I squared is -1. -1 to the 7th power. Again, and on this power, if it is an odd number, then your answer is negative. If it's an even number, your answer is positive. So this is -1I, so that's -I. So I think it is easier to follow this pattern than to write it all out, because sometimes we'll have even larger numbers. So let's see. How about if I do I to the 98th power? That would take a lot to write out. So instead, I'm just going to do 98 divided by 2. Right, so if I do 98 divided by 2, it's 49 times. So I'm going to have I squared to the 49th power. So I have -1 to the 49th power. And then this exponent is odd. 49 is an odd number. So that's just going to be -1. I have I to the 39th power. Again, I'm going to do 39 divided by 2. So that means I can do I squared 19 times. That gives me 38. There was 1 left over, so I'm going to have an I. And then again, I have I squared. So that's -1 to the 19th power times I. And a -1 to the 19th power, well, that's going to be a -1 times I. So that's a -I. And let's see, I'll do the last one maybe. How about just I to the 77th power. So I'm going to do 77 divided by 2. There's 1 left over. So I'm going to do I squared to the 38th power. That gives me 76. There's 1 I left over. So I've got negative 1 to the 38th power times I. And this time our exponent is even. So that means this is going to be a positive 1. And a positive 1i is just going to be I. Okay, well, hopefully that helps a little bit. Despite my confusion with the negatives. I apologize about that. I just didn't want to start the whole video over. Yeah, so hopefully that gives you a little bit of an idea.